Lane. I'm zooming in. What's up, dude?
Hey, how are you?
We made it. All right. So for people that don't know you, we met, I guess, about a decade ago almost.
A decade, yeah. We've been running the same circle. Well, I'm not from the LA area, so I wasn't running in those circles, but I was going down to the Build conference and Build community and some of the burner stuff going back, I don't know, 10, 12 years, something like that. Yeah.
Oh, sweet. I first heard of the space elevator. So for people that don't know, you run a company. Are you still running Liftport, or you founded it?
Yeah.
And that is focused on building a space elevator. And I got into it from, I guess it was like in the late 90s or early 2000s, playing Civilization.
Yeah, right.
And one of the wonders in the game, the wonders of the world that you could build, was a space elevator. I'm like, what in the hell kind of fantasy concept is this? An elevator all day that's going. And then, so it was on my mind for years. And then I came across your company, and I was like, well, this is like actually happening. And so we got to talking, but then at some point you told me that the Terran space elevator, I guess you would call it, was too expensive, or gravity was too intense, or what was it?
So, all right, I'll give a little bit of history here. Under the NASA umbrella back in 2001, 2, and 3, that's when I joined the project. I was the second guy full-time on the team. Dr. Edwards led it back then. And I came at it from the same perspective you did, that this is straight up science fiction. But as I understood, the NASA mandate was like, where's the dividing line? Like, where's fiction, where's fact, and where are we, right? So it was an assessment. And Edwards surprised an awful lot of people when he showed that the physics, the chemistry, the engineering were solid. They were not doable at the time. All right, that's an important caveat, but that the physics stood up. And so what is this thing? If you can imagine a ball and a string, spinning it over your head, the string in the middle stays straight, right? Okay, so let's expand that to an Earth-sized system. The Earth is rotating. We have a counterweight attached to a string. A counterweight's the satellite, attached to the string. And once you have that, you can clamp onto the edge of the string and climb up into space. Now, I completely stand by the engineering and physics of that. Over time, I have changed my mind in some really significant ways. But back when we were working on it, so under 2001, 2, and 3, under the NASA umbrella, 3, 4, 5, 6, and 7 under the first version of Liftport, we were working on nanotechnology materials for the string. There were a couple hundred labs in the world working on that stuff. We definitely have some firsts. We did some really cool stuff there. And then we also were working on the mechanical process of climbing. So we built high altitude balloons tethered to the ground with robots climbing back and forth. And we got up as high as a mile because we wanted to understand the mechanical processes. So I had a team of about 14 people back then. When the real estate markets collapsed in the U.S., my wealth came from real estate. And so when the real estate markets collapsed, I got crushed. And it's a well-known story. There's no surprises here. I went from a 1.7 million net worth to negative 600,000 in 24 hours. So it was a bad day. It was a bad day. And that meant we wound up having to close the company, which was really pretty tragic. And then fast forward, over 2008, 9, 10, I'm starting to kind of have these epiphanies that I'm less committed to the Earth elevator and more committed to a lunar elevator. And that's because we can build an elevator on the moon now with current technology. And I think that was the key to me, was that we could do that. And so that's where we are. We restarted the company in 2018. We were actually making some solid progress. And then the virus hit and the world changed and we almost went out of business again. We didn't go out of business, but we almost did. So this is kind of we're in a reset mode where trying really hard to get back into the business of building an elevator on the moon. So that's where we are.
You guys have been in touch with Space Force as well, I think you mentioned. And so I can see like the government, I don't know if the Department of Defense has issued funding or anything to Liftport, but that would be a company I think would be a smart move to kickstart.
We would love that. So early, maybe 2018, maybe 2019, something like that. We went out now I've had a good relationship with the Air Force for a long time. Just to know that I'm a former US Marine. The Marines don't want to build elevators, which is unfortunate because I think the idea of a Space Marine would be great. But I've gone out and lectured at the Air Force Academy, I think three times. The first was all the way back in 2003, I think. So the Air Force has been really in the background. Like you can't say the Air Force, right? Because there's no one person there. But we have quite a few allies in pretty senior roles. With originally the Air Force and now several in Space Force. So we have not gotten any funding. We have submitted for some awards that we didn't get. Same thing with NASA, same thing with the National Science Foundation. So I think we have a pretty good shot at getting some grants from the National Science Foundation. We're just submitting those now.
You mentioned, I wanted to ask about your past a little bit. Before you founded Liftport, you had worked with, we said you were in the Marines at one point. What was your life like before that, leading up to the formation of Liftport?
I've had a pretty interesting trajectory. I really did. Was never a good student. I was always that troublemaker student. So I had a pretty low high school GPA. My dad was in the Army. My mom was in the Army. Aunts, uncles, cousins, grandparents, Air Force, Army, Navy, Marines. So it was kind of foreordained, if you will, that I was going to go into the service. I was there for 4 years, got both meritoriously promoted and almost lost my stripe for being a troublemaker. So both of those things happened, very, very good and very, very bad. I knew that the Marine Corps was not a career for me. So I got out. I was really fortunate that I had a captain who taught me investment management. I was 19, 20 years old, and he was teaching me about the stock market. So that was my first role out of the Marine Corps. I was an investment advisor. I had control over about $4 million and influence over 40 million. And I was 22, 23 years old at the time. So that was a pretty big deal. And I was, because of my bosses, really aware of infrastructure. Sounds super boring, but keeping the lights on, keeping the roads working, plumbing, electrical grids. That's what my bosses invested in. That's what I learned a lot about was infrastructure. I wound up going to Boston University for a while, left and started an internet company. So I was one of the earliest folks working on an internet company back when you still called them internet companies. Like nobody calls a company an internet company anymore, right? So that would have been, by that time I'd bought my building. I was 28. I had 24 people working for me. It was 1995 to 2001. Started an internet company focused on electronic commerce. So that was early stuff. We built the first online grocery store for Safeway. It took the pandemic in 2020 for grocery shopping via the internet to become a norm. But we built a grocery store for Safeway in 1996. It was supposed to open Labor Day weekend, 1996. It never did. So fast forward, the internet company closes, and I'm sitting in my early 30s with, an above average net worth and trying to figure out what to do with my life. And I'd always been interested in space, so I started doing space. And if your very first project in space is the space elevator, everything else is pale by comparison.
It's one of my favorite things, personally. Sorry to interject there.
Yeah, no, please. I'm curious. So you heard about the elevator? Give me a year. When was that?
I think it was when I was playing Civilization 3, which was like 1999 or 2001 ish.
Yeah,
when it was like in the 90s, I think, and then it would be, I think. And then, so it was always on my mind as like a fantasy, kind of like those electromagnetic slingshots that you can have in orbit, where like people accelerate on like a maglev and shoot your content towards the other planet's orbit, where it'll catch it in a reverse slingshot and it'll like slow it down. So I'm like, okay, I've got these fantasy concepts, but I guess it was 99. And
let me put a slide up for a second.
Yeah.
I got this. This always makes me laugh a little bit.
Oh, well, as you're pulling it up, you said you were involved with NASA too, I think.
Yeah, I didn't. I was more of a contractor. I didn't officially work for NASA. The contract that Edwards had was what's called NASA Institute for Advanced Concepts, and so NIAC, back then, its mission was to kind of take ideas that are pretty far-fetched. I am not able to share my screen. That's very peculiar.
Do you have the present button down bottom?
I do, and I see it, and it's there, but it is not actually giving me the windows. So let me just start over here. So now Edwards had the NIAC contract, and then I worked with Edwards, and then we jointly created. Ian, I had all this stuff queued up before.
Oh, good. Yeah, we'll figure it out. You might need to be logged into StreamYard in order for it to function, but maybe not. I don't know.
Let me see. I think this works. Yeah, so he had the contract, and NIAC was supposed to look, 50 years into the future. That was its mandate. It has since changed, and it now looks 10 years in the future, and that's a very different animal. But those were kind of the NASA days. All right,
do you think is it better now that it's looking 10 years in the future instead of 50?
I'm kind of mixed on that. I understand why they do 10 years, because that's doable tech right now. Like NASA can start slotting those ideas into their current missions. For example, the Martian Ingenuity helicopter that's on Mars right now was a NIAC project 8 or 9 years ago. Right. So that's great. I love that. And then there's a friend of mine, Quinn Morley, has a NASA proposal, a NIAC proposal for some developments on Enceladus and Titan. And that's the kind of stuff that gets slotted into, they're called programs of record. Anyway, so what I wanted to show you was this article. You can kind of see it says Popular Mechanics in the background, right? So this came out July 2002. Edwards was finishing the NIAC document maybe 9 months later, maybe 7 months later. So this is what the world thought a space elevator was: this giant, massive structure, rigid steel and glass, titanium. You can see there's an old school space shuttle there docking to it. That's what the world kind of thought the space elevator was until Edwards, and to a lesser degree me, had some of our breakthroughs, and the breakthroughs were that the materials were the only thing that were not yet available. Everything else was necessary for the elevator was available. Now, I told you I had some epiphanies and changed my mind on some things. Not to throw my friends under a bus, because I really have a lot of respect for the people in the space elevator community. But I disagree with some important stuff there, right? When Edwards and I were writing those original documents, there were only 400 satellites in the sky. 400. And imagine not this version, but the version that Edwards ultimately proposed at NIAC. I can probably find the old paper. It's worth reading. But it imagined that you were a ship in the ocean with a ribbon, not a steel structure, and that if you move the boat, you induce an oscillation on the ribbon, and therefore you could dodge satellites. Makes a lot of sense when there's 400. Today, 20 years later, there's 8,000, and there's designs, we call them paper satellites. There's designs for 1 million satellites, 1 million, right? So everybody I talk to, I'm like, go outside tonight, look up at the night sky, because somewhere in the world, every 2 days, humans are launching new satellites. And that makes the elevator harder and harder to build.
I was just over on a NASA channel last night. I guess I should have saved the channel. And you can actually go from satellite to satellite, and it like zooms in on them, and it gives you and it shows you what they do.
Yep.
Here it is. SDO NASA Science. This thing's incredible. Here, I'll pull this up. This is very cool. If you want to learn about satellites and things, this is like a 3-dimensional thing. So you can see the planets, Mercury. There's Mercury. Yeah. Here's one called Parker Solar Probe. Let's check that out. Click. This is if someone wants to go science.nasa.gov/mission/SDO. This is the Parker Solar Probe. This is from 2018. Just a satellite. This is what it looks like. And then you can go from satellite to satellite. There's so many more. Here's OSIRIS-REx. This is from 2016. And these are all NASA satellites. I don't see any of the private
these are all
satellites.
NASA satellites. They probably don't have NOAA, National Oceanographic and Aerospace Administration. They probably don't have NOAA in there, and they almost certainly don't have Space Force, Air Force in there. But these are great satellites. These are, I mean, this is amazing. I love the James Webb. I'm going to go probably, they've got a movie out now. They've got a movie out for the James Webb Telescope. I'm going to go probably see it next weekend. That is an amazing machine. And next to the International Space Station, that's probably my favorite machine that humans have ever built.
It's really interesting to get a look at the satellites too. They're just like big boxes. Some of them just look like big network boxes with a couple of solar panels.
No, that's not true. The ones you just saw, yes,
that one was complex looking, though.
Right. I mean, that was a multi-billion-dollar system. But a lot of the satellites are this big. They're called CubeSats. They're 10 centimeters by 10 centimeters by 10 centimeters, and some of them are 3 by 10, and some of them are a little bit bigger. And certainly the stuff that SpaceX is putting into the sky is quite a bit bigger. But there's been a revolution in satellite development over the last 20 years, right? There's two breakthroughs that, to me, changed the equation for the Earth elevator. Miniaturization of satellites. Instead of something the size of this room, you got satellites that are the size of this thermos. So that's a big deal. And then also reusable rocketry. That's completely changed the game. So as those things were happening, that's when we started focusing on the lunar elevator.
So question about the dodging satellites for the elevator. Is it more about the dodging them with the tether dodging them, or the actual elevator? So could you use like waveguides to get, instead of an actual physical tether, like a beam of light or like hypersonic sound that's like so densely
sound is only going to work while we're in the atmosphere. So that's really here, and we want to get up here. So that one isn't. But
could you use vacuum to ballast as like a reverse ballast so that you vacuum out the structure and then it just floats up the rest of the way with like an ion thruster or something?
You're going against gravity. The Earth is really, really big. Gravity is that force that keeps everything down, and it's the reason that we have an atmosphere. So no, the vacuum of space is not strong enough to empty out a tube to pull you up.
If we vacuumed them out on Earth and used it as like a balloon, basically, so they have elevation and they can go up that way.
No, you're still going up against some forces that we can't. You're going to ultimately use a rocket one way or the other if you're doing that. Using light to propulse things, that's really been interesting. I've known a couple people that have tried really hard to build light-based systems. So far, not a lot of luck. Jordan Kerr and Lake Maribel both died, and so they were pioneering. Jordan Kerr used to work with me. He was an advisor to my team. He and a guy named Tom Nugent, with my very good graces, left my company, and built their own company to focus on a NASA competition. This was back in maybe 2005, maybe 2007. No, definitely 2006, definitely. And NASA was having this competition for space elevators. They would have a ribbon, and they'd have a really small robot that was powered from the ground, climbing up the ribbon using a laser. And so that was pretty new technology back then. They've really done a lot with it. Tom's company has changed names and brought in some new people. Let me think about what that is. They've done some remarkable stuff, and they have really grown. So, but they're not trying to do propulsive technology anymore.
My other question is, if you had a ribbon the entire way from geostationary orbit all the way down to a base station, except there's a part of it where there's no ribbon. It's just like the top half and the bottom half of a ribbon, and the area where the satellites go through is nothing except for maybe like a really amorphous mesh that things can go up and down on, but also things can pass through.
So the elevator ribbon is designed to take certain amounts of impact, because there is orbital debris up there. There's natural occurring cosmic debris out there. So it's designed to take a hit. But here's the thing, right? If you're a farmer in Kansas, depending on Starlink to drive your tractor, and a Starlink satellite hits that ribbon, both things are broken. The satellite is too fragile, and the elevator string probably is not strong enough to withstand the hit.
I guess then if you had like the top half of a tether and the bottom half of a tether that were magnetically held together, but there was a gap.
So I'm not sure how you would do that magnetic gap, but the satellites are at different orbits. Some are coming in at around 200, 300, 500 kilometers. There's a lot of stuff happening there. 700, 900 kilometers, a lot of stuff happening there. Up to 15,000, 20,000 kilometers, a little bit of stuff there. There's not, and they're coming in at different angles at different times of the day, over and over and over again. And there's not really a way to kind of process where and when. I mean, we have some notice because it's orbital mechanics and we can just work out the math. But when you have that many, there just doesn't seem to be a way yet to avoid that. And you've got companies like Blue Origin and Kuiper and SpaceX and Starlink and Starshield, because they have a military version. There are several constellations that number more than 10,000 satellites. Um, and so there's not just the volume of stuff that's up there makes it really, really challenging. And also, the point of building an elevator in the first place was low cost transport to orbit. You've got SpaceX dropping the cost by a factor of 10. Other companies are following on right behind them. Rocket Lab, Astra's a little bit in trouble, but Relativity is doing really well. Virgin, it's been bumpy for them, but they're doing okay. Sierra's about to launch their new Dream Chaser. That thing's been in development for 10 years. And that's just in the United States. And then you add in UK is building a fleet of spaceships. India has done an amazing job recently. China just landed their competitor to the Falcon 9, landed it. So we've got a world where reusable rocketry is even less science fiction than space elevators, right? So, I just see that it's going to be the technology is still sound. The physics still work. The engineering still works. What they're up against is the economics of the world. All of those satellites, those 8,000 satellites and soon to be 40,000 satellites, the economics are that all of those companies and all of those nations have legal rights of way that the elevator is going to have to navigate. And there's literal billions of value attached to those satellites. Last year, 2022, the space industry generated $526 billion in revenue, $500 billion in revenues on $250 billion of assets. That's remarkable. And that means that's a lot of lawyers that can be like, don't hit our satellite, right? And so they've all got rights of way, economic and legal rights of way.
It's funny because I'd be like, don't hit my space elevator.
Right, but it's a first come, first serves. And there's all kinds of regimes out there. There's the International Telecommunications Union, UN, the FAA, the FCC, Department of State, NASA, NOAA. I'm forgetting one, but I mean that's those just 7 that I can rattle off the top of my head.
Let's pivot to what's realistic, which is the lunar elevator.
Okay. Yeah.
I could go on and on and on about Earth and space elevators. That'd be fun to do, just to knock ideas around. But the lunar elevators. So you guys were like, okay, there's a lot of shit in the way, basically, right. Satellites, gravity, whatever. Let's focus on the moon and get one up on the moon. What's it been like since you pivoted?
Well, so I mean, honestly, every day the elevator on the moon gets easier and easier, right? There's more activity. There's NASA has a program called the Artemis Accords. There are 32 nations that have signed on to the Artemis Accords. And that's how do we work on the moon together? And that's very much American-led. China has something called the ILRS, International Lunar Research Station. They have 8 countries. That's 40 countries that have all declared they're going to the moon one way or another. 40 nations are going to the moon one way or another. And I think that's remarkable. So, all right, so that wasn't happening 10, 12 years ago when we started to pivot away from the Earth elevator into the lunar elevator. That's all happened in the last maybe 4 years or so. 10 years ago, nobody was talking about the moon except crazy people like us, right? So we're like, okay, if you build this elevator on the moon, what happens? Well, we learned that there's water ice on the moon. So now we can take water ice, H2O, hydrogen and oxygen, both of those are flammable. That makes rocket fuel, right? So you can go to the moon, harvest resources off the moon, and now you've got rocket fuel for the rest of the solar system. So that's a huge breakthrough. We, of course, had nothing to do with that. Like, that's Mother Nature doing that over billions of years. But certainly the world is paying attention. And so that's why I say, like, every day it just gets easier and easier to build a system for the moon, because other companies and other countries are all focused on that as a near-term destination.
Is it the same? If I'm cutting you off, I apologize. Just keep going. Yeah. Is it the same technology that you would use from the Terran elevator to the lunar elevator?
It's a little bit different. Let me see if I can show a different slide here. Hold on. It's a little bit different. The mechanics are the same. The physics are a little bit different.
What is it like? The gravity is like an eighth of the Earth's gravity, or is it way less than that?
A sixth.
A sixth of the Earth's gravity. Does that mean literally you can jump 6 times higher?
You can, yeah.
Jeez, wow.
Yeah. Too many slides here.
I wonder what the loudness is.
All right. I'm not going to mess with that. It's too hard. So,
yeah,
all right.
You got it.
If you can see me, here's what we got. We got.
Oh no! Feel free to pull up the slides if you want to grab them. There's no rush.
Here's the Earth on this side. Here's the moon. All right. So there's the physical middle. We don't care about that. What we care about is the gravitational middle, because the Earth is so much bigger. The moon's gravity is so much weaker. The gravitational middle is here. All right. So that's called the Lagrange point. EML1, Earth Moon Lagrange 1. It's a worthwhile Wikipedia article. So that's what we got. We're going to take conventional rockets out to the Lagrange point and then drop a string down to the surface of the moon, pull that string through the Lagrange point towards the Earth, not touching. It's still a long ways away. But the Earth's gravity keeps this string straight. All right. So a Earth elevator is based on centripetal acceleration. So we call that a centripetal elevator. A lunar elevator is based on gravity. We call that a gravitational elevator. So we're going to build, and those two elevators, by the way, super important point, those two elevators can be constructed anywhere in the solar system. And you could imagine elevators on the moon, on Mars, on all the planets and all the big moons of the solar system, and have an intersolar network that just throws you from one elevator to another, from another to another, and it opens up the entire solar system. So those two elevators open the whole solar system.
Could you build a gravitational elevator on Earth that is tethered towards the sun and has the sun's gravity?
You could. What's a little bit different about that is, as the Earth is spinning, where you have to have a track on the equator all the way around the equator, so that the ribbon is pointed towards the sun. So if an object is spinning fast enough, it doesn't make sense to build a gravitational system. You want to build a centripetal. But that pair, one or the other, you wouldn't have both, but one or the other could be used in almost all bodies in the solar system.
Yeah, so, like you'd have a centripetal one from the Earth out into orbit, and then a bunch of gravitational ones out in orbit to the sun or to the other planets and stuff.
Exactly. Yeah. So that, I think that's pretty exciting. So this lunar system, because the gravity is easier, because there's no atmosphere to fight, because there's no lightning, because there's no earthquakes, it's just easier to place this elevator on the moon. And so if you're looking at the full moon any night, that middle is called Sinus Medae, and that's where we're going to locate the elevator. Now, everybody wants to go to the South Pole. Those 40 countries I was talking about, they're all focused on the South Pole because that's where a lot of the ice is. I think there's value in going to the equator also, but what we're going to see in the pretty near future, 2 years, 5 years, there's going to be a launch that happens, I think January. You're going to have smallish rockets landing on the moon, and landing on the moon is really hard. There's a reason we haven't been back with people in 50 years, because landing on the moon is really hard. India had a $7,500 million crater 2 years ago. Israel had a $150 million crater 2 years ago.
Crater? What do you mean? Like they exploded? They hit and blew up?
They hit and, well, blew up is maybe the too strong word, but they came in too fast. They lost communications and they splat right.
Did they lose humans? Were there humans on board?
People. They're all robots. We haven't sent humans back in a long time. Although that's where we're at now. The Artemis Accords is focusing on sending humans. China's planning on sending humans. So China is aiming to get people to the moon by 2030. NASA claimed they were aiming for 2026. Nobody thinks that's a realistic date. They haven't even got some of the core technologies built yet. So, but 2025, 26, 27, somewhere in that range, we're gonna have people on the moon again.
Do you think it's a matter of just learning the reusable rocketry entry and on the surface and back again?
It is definitely part of that. That's one of the things what we like about this lunar elevator is that it makes soft landing on the moon easy. So did you see those pictures of SpaceX trying to launch their Starlink a couple months ago?
No.
A year ago? They referred to it as a rock tornado. That down here in the atmosphere, that rocket had so much exhaust that it destroyed equipment all over the region. Like for a mile and a half, stuff was destroyed. Rocks were just getting thrown up and landing in the parking lot and shattering employees' windshields, right? But then the main site, they melted into slag, some of it. So take that same amount of energy, drop it on the moon where there isn't an atmosphere to contain it, and all of that exhaust is going to sandblast the region for miles and miles and miles. Not really good if you're in a spacesuit anywhere near that entry point, right? By the way, there's an organization called For All Moonkind that is trying really hard to preserve historic sites on the moon, all the landing sites. How tragic would it be if Armstrong's first footprint was sandblasted because a rocket came too close and their exhaust just blew the whole thing away? That thing as it is will be there for 1 billion years. But if we have too many rockets coming in the wrong way, it's going to erode that entire environment. So I'm a big fan of Professor Hanlon's work over there. Anyway, so what we want to do is we want to change that paradigm a little, come into the elevator, take the cable car, we call it a lifter, down to the surface of the moon, and then go do what you're going to do. So we want to provide that last mile transportation to the lunar surface. But also that Lagrange point station could be a giant, mind-bogglingly large space station, a station that houses personnel, manufacturing, storage, equipment. I think we're going to wind up building giant solar panels there, using lunar resources, build solar panels at that space station, and then ship those panels not to Earth, but to the orbit of Earth, and so provide clean, limitless energy to the top 300 cities of the world.
Yeah, we've also figured out how to use electrical current to turn carbon into graphene and hydrogen fuel out of Rice University. So on board the space station, we could just be taking rocks, taking dirt from the moon up and turning it into hydrogen and byproducts of graphene that we can use to construct things in orbit and stuff, or send it.
Yeah, you're going to do a lot of mining and processing down on the surface of the moon, and we're going to carry the really valuable stuff up to the space station. But yeah, we're going to do a lot of off-Earth manufacturing. They call it ASAM, assembly and manufacturing. What's it called? Or OSAM, orbital space assembly and manufacturing, servicing and manufacturing. That's going to all happen at space stations.
I can picture drone swarm delivery or swarm construction, where we have 10,000 drones all moving in synergy with the computer program to move pieces and parts around and weld them into space into shape.
Let me show you this this video here, because that's definitely a part of our future. Now, I don't know if we're going to be the ones who do that, because there are some companies that are pretty far ahead. This is our YouTube channel, youtube.com/Liftport. This is the video I want to show. So here's our construction. I'm not going to go through the whole thing, but I want to talk about some of the robots. So we're gonna launch probably from Florida, probably a SpaceX Heavy right now. I'm a big fan of the Starship. There's some artist liberties here, but we're going to send all the parts up in a single launch.
Well, so your audio was distorting there. Can you repeat that part? Oh yeah, that's better. That's better.
Sorry, that was YouTube putting. Let me come back a little bit.
Yeah, what's that thing coming out?
So that's all the parts. So down here, that is the landing anchor. We call it the lift port. There's two parts here. These kind of circular pieces are going to become space stations, and this rectangular piece is the lifter. So we're able to launch all of this in a single launch. So it's a roll the dice moment. This is a single point of failure moment. We can put everything that we need into a single launch to build the first set of elevator components. And then this piece, the end of the rocket, that becomes the counterweight that we use. So that we're not even throwing that away, right? That's a valuable part of the infrastructure. So we get out there and we inflate these habitat sites. So these are modeled after a company that's gone out of business, Bigelow Aerospace, but their modules are really smart. They have some stuff flying on the space station right now. There are about 9 very credible space station projects going on right now. I really am a fan of some folks up north here called Gravitics. There's Axiom that's getting a lot of attention. These companies have $500 million in their checking account. Is that enough to build a space station? Probably not, but it does make you very credible, right? So Axiom, Blue Origin has their orbital reef program. Starlab from NanoRacks and Voyager, right? These are all companies that have really credible teams, have a history of building great hardware. So even though we model this after a company that went out of business, this video is about 10 years old. Even though we modeled this after a company that went out of business, these modules are very real. They are in production at some level in a couple places around the world. So that becomes a space station, and this space station can get larger and larger and larger and larger. We are only going up with 4 modules in this first launch, but there is no limit because you're at that gravitational balance point between the Earth and the Moon, right? And then we're going to land this down at the surface of the Moon, that place that we called Sinus Medae. There's some pretty interesting stuff around there. It's a good site for us. There's resources. There's titanium. There may be some other stuff nearby that's useful. So we sink in to the surface of the Moon, have this big hook that just keeps us there, right? And then on the top end, So now we've got a string that's attached to the surface of the moon, another string that is pulling gently out towards the Earth, again, not touching it, it's a long ways from the Earth, but that the gravity of the Earth is subtle enough but consistent to keep that string straight. And now we drop our lift port sight down to the surface of the moon. We unfold it, and this is the piece that's actually doing the work. This is the lifter that climbs back and forth. And we've got some pretty unique designs there. And Ian, this is the piece I was going to talk about, was this swarm army of robots running around the surface of the moon doing the work of humanity, collecting samples, collecting stuff. Now, we're probably not the folks that are going to build this. There's another group called Offworld down in LA. They've got a really strong team focusing on the robotics side of it. So we certainly want their help with stuff. And there are other groups. There are other groups working on lunar mining as well. Gonna jump forward a little bit. So they're going to bring cargo back to the lifter, and then the lifter is going to climb back up to the station. It's going to drop its cargo down into the pods, right? So the lifter is above here, and this is the cargo pod. But then once the lifter is up doing its thing, right? It's gone on to space station. It's gonna send cargo back to Earth. So these little pods are gonna come off. They look like little missiles. I don't like the artistic part of that. Truth is, once you get past the Lagrange point, you can just let gravity pull anything that you want towards the world. So
that's all. Can you use ion thrusters just to gently nudge them?
Yeah, they will be. That's exactly right. Yep. I'm a big fan of ion. I didn't mention it, but in the early part of this video, there was going to be some ions. Take a look at what's happening down here. While the cargo system is up doing its thing, the little robots on the ground are doing really important work. We are literally making a mountain from a molehill, because this piece of infrastructure is the only thing holding it to the moon. We want to make sure that we stay there. So we're building our own mountain to make sure that we stick in this one spot.
This is what I was going to ask you this about 5 minutes ago, and I just kept my mouth shut. Is there any value to burying the lift port itself?
Yep.
Yes. Yep. Thank you.
Yep. That's exactly right. Yeah. This set of imagery came from a guy with I think he has a double master's now. One of them is architecture. The other one is space architecture. So that's where, some of the source material here came from.
So a question right off the top. It looks like we're rolling into the end of the animation.
Yeah.
Is there any value to having multiple strings, like 6 of them? So you have all day, you have things coming up and down, or 60 of them, for instance. I mean, obviously, maybe one is the starting point.
Yeah.
And then.
Yeah. And that's definitely going to happen, right? So, in engineering, you don't want a single point of failure. We refer to this as Sputnik-like simplicity, right? That Sputnik was, the first satellite, and what made it remarkable, not just because it was first, because it was as simple as it could possibly be, and no simpler, right? So what I just showed you is the first version. But what's going to happen is you're going to take one ribbon and you're going to put another one, and another one, and another one. So you're going to make it wider, and that makes it stronger. But also from the Lagrange point station down to the South Pole, down to the North Pole, down to the center, you're going to have multiple sites, because if you don't, you have a single point of failure. So we want to mitigate that as quickly as we can. But what I've shown you is kind of version 1. There will be more complicated versions going to different destinations and also acting as safety lines.
I'm also thinking about other space stations than the one at the Lagrange point potentially, but that's kind of a I mean, we could talk about that too. Is there any value or concept of doing that? So like above the one over the South Pole, you have a station above it, and it's connected by tether to the Lagrange point station and the base station.
I expect you're going to have a thriving ecosystem of space stations. Most of them are going to be around Earth. Some of them will be around the moon. NASA's already working on one project called Gateway that will be not around the moon, but near the moon. That one I think is going to be useful. There's going to be a whole community of space stations that shuttle back and forth. There'll be rockets, but there'll also be space stations that shuttle back and forth to Mars. We're in a really exciting era. It's different from anything we've ever been in. Humanity has never been in this spot right now, where we're about to go en masse to other worlds, right? So the moon is the first easiest destination. It's not the only destination. I think you should look back at this video in 10 years to see how many of my predictions are right, but I'm pretty sure there's going to be a lot that's right. So we've gotten really good at rocketry, right? So this is what I refer to as the grand architecture. We've gotten really good at rocketry. We are launching a rocket every 2 to 3 days somewhere in the world. And we've gotten really good at satellites. The next piece is space stations and tugs. We're going to have a whole ecosystem of tugboats out in space. It's going to be going back and forth to space stations. I think the lunar elevator is going to be a part of that, but then also it's going to be lunar development en masse, which means kind of like Antarctic science stations at the South Pole, and I think there's some in the North Pole too. But there's going to be research sites all over the moon, but they're all focusing on the commercialization of the moon, right? And then once we do that, now we've got an industrial base on the moon, an industrial base on Earth orbit, an industrial base at the Lagrange point. That makes it easy to get out to the rest of the solar system. And that's, that we're talking 2 years away, 5 years away, 10 years away. A project that got started in 2008, it was called the Google Lunar X Prize. Google offered $30 million worth of prizes to go to the moon, land a rover, drive half a kilometer, and send back high-def video. Now, that didn't happen. That was a 10-year prize. It ran out. They extended it. It ran out. They extended it, and it ran out, and that was it. So companies tried doing that. There were about 20 companies. Well, fast forward, the team from Israel that crashed, they were part of the Google Lunar X Prize. India was part of the Google Lunar X Prize. There's 2 systems going up now, Intuitive Machines and Astrobotics. For a moment, for literally 2 weeks, I was a part of the Astrobotic team. There's a funny story there, but they're going to the moon, and they all started in the 2008 program, and it just took them a long time to get there. But now there's real momentum, and I think there's north of 100 missions to the moon planned right now. 100. The moon is a thriving ecosystem. It's going to change everything. So the elevator is a portion of that story, but it's not the whole story. There's a lot of other stuff.
When we got talking, I guess 2013, I sent you the first message or something like that. But at some point in our conversations, you mentioned that the materials were not there yet for the tether. And that was the biggest hurdle. And then I hit you up like 5, 6, 7 years later. And I was like, yo, graphene nanotubes. I think graphene's the way. And then we lost contact for a year or so. And then I saw on your website, you're looking at carbon nanotubes.
Yeah.
Where are you at now with materials?
So the Earth elevator needs those super strong materials. And there's some really good stuff. We both know what's happening down in Rice. Rice University is not the only story. There's some folks out in Cambridge that may have cracked at least 2 of the 7 problems. So they're doing really great work over there, and I think that they will get the carbon nanotubes at the scale and the strength that we need. But my system, that's for the Earth elevator. My system for the lunar elevator doesn't need that. There's 14 materials that already exist, that are already mass producible, that are all strong enough for a lunar elevator. There's some stuff that needs to happen. No, we don't need carbon at all. Spectra, Dyneema, even Kevlar, bulletproof vests material. Now, I use Kevlar because other people know what it is, but that stuff goes to dust if you have enough UV on it. So it's strong enough, but none of them are perfect. None of them are the Goldilocks materials. So we probably are going to have like this core material and then some sort of coating over it. Because some of them have problems with elongation and creep. Some of them don't handle UV very well or thermal changes. So none of them are perfect, but 14 of them are strong enough. So that is not a problem.
Is carbon viable if you were able to produce it in mass?
It would be. Yeah, absolutely. And would you prefer a carbon nanotube graphene ribbon over Spectra and Dyneema? Yeah, you probably would. But we don't have to wait for it, is what I'm saying.
I also like with carbon the structural, like the crunching capacity, the ability for it to bounce on itself and produce electrical current through piezoelectricity.
Yep.
And it can store the charge and conduct the charge. You might actually turn the tether itself into a power station.
You probably won't, because of the design of the tether. You're probably not aiming for that, but it probably is going to be conductive. There was some early work on whether you could. So we talked a little bit about space-based solar power. So you take a giant satellite about a mile by a mile, and you place it over. You're in Washington D.C., right?
Yeah.
We're gonna take one in D.C. and place it in orbit over D.C. We're gonna take another one, place it in orbit over Seattle, London, Paris, Beijing, Tokyo. We're gonna place these orbital satellites that are collecting clean, green, limitless energy, and we're going to beam that power down to the ground to provide power for 40% of the global population. And so one of the things that came up in the early days was, do you use radio wave energy to beam that power down, or can you use a cable, a nanotube ribbon, down to the ground? And over 22,300 miles, it actually made more sense to use the power beaming solution rather than the connectivity solution.
So kind of like lightning, you would just shoot an arc of whatever
at
your base station.
Yeah. The radio waves off of space-based solar power are no different than the radio waves in your car. So if you had a receiving antenna, you could actually generate power off of the radio station in your car. So or the radio stations that beam to your car. So that technology has been known for a long time. But building an elevator on the moon kind of enables that kind of future. And I don't think we're that far away. There's a big university in California that's working on it. The Air Force Research Lab and DoD has a big project in the sky right now. Those are happening. The European Space Agency has really put a lot of effort into space-based solar power recently. So that technology is on its way. And that's part of this grand architecture that I'm describing.
Via that pulling up the lunar elevator thing, were there more pieces that were worth mentioning? I think only because we've gone an hour, and I think it might be wrapping it up on my end. I mean, sure. We could do this over and over again.
Yeah. The thing I wanted to say about the lunar elevator is it's way less expensive than people think.
How much? Roughly.
We're looking at $600 million to build the whole thing. That's launch included. The string is $35 million. $35 million just for the string itself. All the rest is kind of the development parts. We've got a design cycle that we know where the holes are that we have to do some experiments on. We have figured out how to build a business out of doing the science experiments. So there's $1 million experiment, and there's a business behind that that justifies $1 million commitment. There's a $4 million experiment, and there's a business that's valuable enough to justify that $4 million experiment. There's a $20 million experiment, and there's a business that justifies that. So we worked really hard to kind of design a system that was compatible with kind of the global economic system. So $600 million seems like a lot, but I'm in Seattle. There's $5 billion projects in my city alone. So I think it's, we talked about several companies with $500 million in their checking account to build space stations. This is on that same order of complexity and the same order of price tag. And I think the utility, the value of it is vastly higher. So,
and I think of it, I get into the authoritarian mindset where I'm like, tax dollars. I'll use your tax dollars, but it's like if everyone paid $1.50, and that includes like the 2-year-olds. So right. The adults would have to cover the cost, maybe $7.50 for their family. If everyone funded that, $7.50 to get a lunar elevator, like that's totally feasible. If we're going to print 12 billion for some conflict, like we could do $500 million for the extension of our species.
Exactly.
And the leading the way into the space travel and mining industry. I think it's because we're just building an inception point into the value of the mining industry.
It's a curve, right? It's a curve that we never expect. One of my professors at International Space University, I'm a past alum and past president of the ISU's Alumni Association in America. One of my professors said that this is the moment that there's only been one moment like this, and that was when the lungfish came out of the mud and started walking on the land. So that was when a species moved en masse from the ocean to the land. And now here we are, another species is moving from the land to the sky.
I wonder if we're going to genetically modify ourselves so we need less oxygen so that we can live on the surface of Mars and breathe.
I think we will wind up doing a lot of modification. That's probably beyond me. But I mean, if you watched the show The Expanse, the folks that were living on the asteroids, their bodies just biologically elongated over time, and that's because of reduced gravity. And then you start having sex in that environment. And your kids grow up in that environment, and they select for whoever is healthiest. I think that's going to happen both by Mother Nature and that we will speed up Mother Nature's processes. But I don't know that much about biology, so I want to not talk about something I don't know anything about.
Yeah, exactly. I had a couple of super chats I wanted to bring up. This is
great. Hey, hi.
Hydra Shock. Great job on the channel, Ian. This is becoming one of my favorites, along with the Y files. Keep it up. Fuck yeah, dude. I will. I haven't seen the Y files yet, but if they're asking why, that sounds pretty cool. Thanks, man.
Yeah.
We got another one from Farion. This is Czechoslovakian money, I've been told. I like it. This for sure reminds me game Space Engineers, of the game Space Engineers. People like and sub. Nice. Space Engineer. Have you played Space Engineers, Michael?
I don't. I play a different game called it's Settlers of Catan for space. So it's a strategy game. I do know Space Engineers, and there's another one called Million on Mars that is really trying to simulate what it would take to build people, a community on Mars. So I played those a little bit.
Space Engineers is cool. It's like a first-person shooter, except you're basically a space engineer. Literally, my buddy John Paul Larson got me a copy. He's like, "Help me build my space station." I was like, "This feels like work, dude. I'm not getting paid for this." But it's a cool, really cool game.
Yeah.
physically, you know, understanding the physics of space and stuff.
What's the one up in Iceland? CCCP. Oh, Eve Online. Eve Online. I played that for a while, and I loved it does feel a little bit like work, but I love that there's like a thriving community of folks trying to understand. I actually went out to CCP games in Iceland about 10 years ago. It was crazy because their game had 250,000 people in the game, and the country of Iceland only had 230,000.
Whoa.
Yeah, it was insane. And what they did is they brought out. I brought in two friends of mine. One to work. What they wanted was realism in the game. And they said, okay, if you have space elevators, gravitational and centripetal, then that planet is more valuable. But it's also a target. How do you take out the opponent's economic value? So you would target their space elevator. So they brought me in for that piece. They brought somebody in for asteroid mining, the guys from the asteroid mining. There's two asteroid mining companies that were around about 10 years ago. Both of them went out of business. I'm drawing a blank on that.
You'll remember.
They brought in the guy for warp drive. They brought in the guy for asteroid mining, and they brought me in to talk about elevators. So they wanted that kind of realism in their game.
We didn't even get into the defense. That's crossed my mind too. Like, what do you set up turrets? Do you have shields? Do you have like EMP blasts around? You're going to need to defend against lasers and ballistics. So you're going to need armor and shields.
I'm going to count on Space Force for that. I'm a big fan of Space Force. Here's the challenge coin I got from the chief scientist of U.S. Space Force. I like those guys. They're doing amazing work. Those folks are terrific, and I think they're our future. So I made a policy during the Earth elevator days that we did not talk about security. Interesting note, we were doing that work when 9/11 happened. So everybody was asking, what if somebody flies a plane into the ribbon, right? Everybody for 5 years, that was the most common question. And again, being a former U.S. Marine, I don't talk about security. I believe there is security necessary. I believe we have some solutions, but I defer questions on those because it's not a good idea to talk about that stuff.
Yeah, I'd love to have a representative from Space Force on and talk about it more, but obviously we should do that, the three of us maybe, because I know you know people, but we can't. How deep can we go into the legitimate security functions? Because you don't want to blast out, hey, these are our vulnerabilities. These are our potential defenses.
Okay. And I don't want to like overextend your callers there, but the short version is Space Force is surprisingly transparent. Surprisingly. Yes, they're not going to talk about program LMNOP, right? They've got programs. They're not going to talk about those programs in detail, but as an organization, they are surprisingly visible. They share a lot of stuff, and it's because of that other nations have followed. France has their Space Force, Israel, Australia. There's about 5. And then China has always had a military program for space, always. So we're actually playing catch up on that one. But the U.S. Space Force is surprisingly transparent for what it is. So we'll talk about it.
Thanks for coming, Michael. Michael Lane, ladies and gentlemen, liftport.com is the company. And thanks so much for coming, man.
Happy to have it. And I'd love to chat some more. Thank you.
Links will be in the description to follow everybody involved. Everyone, thanks for coming. Have a nice day. See you later.
Good night. Bye-bye.